So I think we saw an awful lot of talks today that sort of highlight the importance of cloud robotics and how it's really starting to evolve and take shape, especially as it applies to industry. So I think there will be a lot of common themes in this talk, things that you've already heard. So I believe somebody else also said, let's first kind of talk about what do we mean when we say cloud robotics, because maybe not everybody means the same thing yet. And also, why do we want to go after it anyway, right? So we've heard a lot about how security is one of the biggest challenges that you have to just to try to address when you're dealing with cloud robotics. Connectivity, I think in a lot of cases, some of the things that we've heard about today in terms of applications haven't so much talked about intermittent connectivity, but this is a really big problem in industrial situations. Mostly we talk about latency today. Distributing work, I think this is also something that to me is very interesting that maybe we didn't talk too much about. We have a lot of classical robotics problems that need to be adapted to the sorts of capabilities that the cloud has and that our local robots don't, right? If a lot of existing behavior and everything has really been developed towards this idea of everything actually running on the robot, and we need to kind of take a step back and think about how can we leverage the cloud in the best way, even though a lot of things will still have to take place at the edge. Right? And by thinking about these problems and coming up with solutions, we get a lot of benefit from the cloud. Right? We get scalability, being able to share information between robots. I think shared learning was just talked about a little bit. That's one example. And we also get a lot of support for DevOps, right? Which is sort of addressing this robustness need, right? Google, Amazon, all of these large tech companies have been spending a lot of time trying to figure out how to build distributed applications and make them extremely robust. There's an awful lot of tooling out there, platforms as a service, things like that, that actually make building a robust system a lot easier. So when I talk about cloud robotics, this is kind of what's in my head. Right? We have sort of an edge to cloud to edge spectrum, right? And the sense, plan, act model, I guess everybody is familiar with, but I sort of think about cloud as just adding one additional stage there, this sharing stage. So as you actually sense things, maybe you're handling things reactively, but eventually, by closing this loop, we reach sort of a collaborative sensing. In the share stage, we have this additional loop, right, where we do some planning, where planning I take sort of loosely, right, to mean like perception and understanding, coming up with state estimations. Then we share those results with the rest of the agents that we might have in the system, and use that to actually further planning and further understanding of the system. And then eventually, all of this results in some sort of collaborative behavior, right? And part of that collaborative behavior kind of drives this collaborative sensing sort of thing. So I see cloud robotics as really like, how do we break our problems apart so that we can sort of match this edge-cloud-edge loop as well as possible, right? So that we can play to the relative strengths of the edge and the cloud. So one super simple example, right, is actually doing machine learning, right, where there's vastly more resources available in the cloud to actually train your models, right, but all of the actual sensing happens at the edge. Right, so first you start at the edge, you do all your sensing of your environment. You move this information up into the cloud to train your models. And then you can actually start pushing those models, in some cases, back down to the edge so that you can have faster refresh cycles and actually drive control loops in this way. And you can you can drive the actions at the edge as well. So how do we sort of think about this cloud robotics problem? We actually sort of think about it in the cloud native sense, right? So there's an awful lot of services and platforms out there that have sort of, like, as I said, been built to actually sort of address the problems that come from trying to build and deploy and maintain a distributed system, right? And cloud native sort of came out of these needs to increase the speed of being able to actually deliver your product and deliver new changes to that product, how to make it scale to many more users. Right? We just heard about the scale of robotics compared to the scale of the sorts of products that Google and Amazon develop. And also, how do we drive the margin? Right? How do we actually use the resources that we have more effectively, right, so that we don't have a bunch of CPUs sitting around idle? Because that gets expensive. And so the way that cloud native approaches this, right, is to create infrastructure as a service. So this is the flexible processing, the on-demand kinds of services, pay-as-you-go, that sort of thing. Stuff where you don't have to maintain it yourself. A lot of the labor is actually taken away and done for you, right? It also is about designing all of your systems to actually be very small and decoupled. One process, one job. You can swap out these pieces as necessary. You can canary things, and components don't have a shared fate, right? And then about orchestrating those things, right? We just heard about orchestrating in terms of API economy. But I think in this case, we mean quite more literally about container orchestration. How do you, if you've broken all of your system apart into all of these small pieces, then how do you actually make sure that they all kind of come up and stay alive and are monitored effectively and everything? How do you deal with resource QoS, things like that? There's lots of available open source tooling for all of these things. So I think for ROS developers, there's a pretty direct simile here between ROS nodes and microservices, right? So ROS nodes tend to actually try to solve exactly one problem, and microservices are generally thought of kind of in the same way. You could actually package a ROS node with Docker ROS into a container, and you can treat it that way as well, right? And you can actually build a graph of all of these things to solve some more complex behavior. But I think one of the main differences is actually in the way that people think about solving this problem in a cloud-native sense versus in a ROS sense. ROS nodes are generally quite stateful. You have exactly one of them in your system. In fact, the master actually kills another one if it claims to do the same job. And in that sense, you can't copy-paste more of them when you need to actually do more of the same work faster, right? More of it in parallel. And microservices are generally about being stateless. This is where RESTful web services come from. So if you have many more queries coming in, you can just copy-paste those processes, you can put some load balancing in front of it, and you can scale. So I think for cloud robotics to really grow and take advantage of the sorts of cloud services that are becoming available now, we need to start thinking about our robotics problems in the same sorts of, figure out how to use these approaches that have been developed for these very large distributed systems for classical robotics problems. So Kubernetes is actually a container orchestration engine that we're actually customizing essentially to be able to run on cloud, on premise, and on all of your robots. And actually, how do you orchestrate all of those containers across all of those different layers, right? So assuming that you've actually figured out how to break apart your cloud robotics problem, you want to then figure out, okay, what you don't want to have to think about or code up the pieces that actually make sure that all of those things that you've broken apart, all of those individual components are all running where they should be and that they're all healthy and that if something crashes, it comes back up. This is the job of Kubernetes for you. In addition, on top of all of these sorts of platforms that have been created for these problems, there's lots of logging and monitoring tools, many of them open source. And those are basically how you drive this robust DevOps experience, right? How do I make a change to my particular SLAM algorithm and then push it out to some small number of robots, make sure that everything is behaving in the way, understand that it is behaving correctly, and then move on from that canary stage to maybe a full launch. These are all the tools that are used every day in sort of the web services environment, and they have a lot of applicability in robotics as well. So our approach towards getting Kubernetes onto robots is what we call Cloud Robotics Core, and we're actually making this available in open source next year. And we think of it as being composed of a few different layers. So on the bottom layer, we actually just have Kubernetes in the certified Kubernetes sense. On top of that, we have added some tools that allow that Kubernetes cluster, this cluster on wheels, more or less, to actually connect up to other clusters on wheels or clusters on-prem or clusters in the cloud, and provide secure connectivity between them, right? And to actually manage your application deployments across all of those clusters. So we're not talking about just an application that maybe has some cloud component and some robot component. These could be arbitrary constellations of components that maybe even span multiple robots, right? On top of that, we refer to this as the app management aspect, and then on top of that, we want to offer the possibility for managed repositories for vendors to actually be able to distribute those things. Something maybe sounds familiar to the Snap talk earlier. And then we start talking about cloud services. And cloud services, not necessarily the ones that are already in existence and used for many different things, robotics included, but cloud services that are built specifically for robotics problems that everybody has, right? So for a mobile robot, you have to pretty much solve the mapping problem, the localization problem, the navigation problem. We'd like to see services in the cloud specifically for those things so that just like when you're getting started in ROS, you don't try to solve those yourself. You take something off the shelf and you focus on the piece of the problem that is interesting to you. We'd like to help make that happen. So it's our vision, essentially, to create this open platform and hopefully grow that into a thriving ecosystem, much the same way ROS has grown into a very vibrant ecosystem. Except that we'd like to take those. We'd like to give ROS developers sort of the opportunity to connect with real customers and drive some real value there, to have real impact. So in terms of those cloud services, we're focusing on a few initially. Mapping and localization. So this is built actually on top of Cartographer. We're extending Cartographer to work in a lifelong collaborative mapping and localizations case. We've been working a lot with Magazino on this problem. Maybe you've saw our ROSCON talk. Just very quickly, kind of how this works. Basically, every robot is running a finite history local SLAM problem. And then that piece of the problem actually functions quite well as both sort of a compression scheme in order to send up just a little bit of data about whatever the robot has experienced recently. And also, so basically doing a little bit of this computation at the edge. And then that gets shared up into the cloud where we can take all of the local SLAM experiences from the entire robot fleet and optimize them together, right? Then becomes the problem of actually making this lifelong. That's what we call the lifelong trimmer. And essentially what it does is tries to look for unique experiences and prioritize keeping those around. On top of that, then we start thinking about higher level problems, like what we call spatial intelligence. And this, I think, is another one of the places where thinking about cloud native development and like the sorts of scalability that can be achieved based on cloud infrastructure gets really exciting. So once we're actually slamming all of this data and coming up with trajectories for all of your agents, and you're pulling all those up into the cloud, right, we can accumulate all that sensor data into the representation of the environment, 3D reconstruction, and then we can start applying machine learning to all of that information and create a semantic map of the entire environment and keep that live and use the observations from all of those robots to keep that up to date and track changes. So that was just a very brief introduction to what we're doing. Thanks very much.
So we have enough time for questions. Yeah. So you mentioned you will be shipping out next year?
Yeah, for early adopters, yes.
Okay. Right.
Yeah, for the platform specific aspect. So Kubernetes on robots and...
how do you select your early adopters? Do they have to apply?
Right now, we're actually doing most of our development directly with partners.
Mm-hmm. So, all right. And for partners which have not joined yet?
Yeah, reach out to us, I suppose.
Okay.
Yeah.
Mm-hmm. More questions to Damon? Yeah, there's one at the very back. Yeah.
I can repeat the question. Feel free.
How much is connected to ROS? How much incubation is there happening?
Okay, so the question was how much is this connected to ROS? And I think you said incubation is happening? Integration, sorry. So we because our goal is really to create an ecosystem around cloud robotics, right? We would like to see more automation in more places. We see ROS as being basically the largest ecosystem of roboticists available today, right? And so we see ROS as like a really great place to start exactly with integration. So we don't, in the like in the slide about ROS nodes versus microservices, there's a lot of ROS concepts that are quite close to the sorts of cloud-native technologies that we think can really sort of revolutionize the way people do cloud robotics. But adaptation is necessary, right? So we're not so much building on top of ROS as we are sort of like building bridges to ROS thoughtfully, right, where it makes sense. So like we don't necessarily advocate for streaming all of your topics up to the cloud because that doesn't really work in a lot of industrial situations. And instead, we look at things like Cloud Cartographer, where you're running this local SLAM solution and trying to compress that data as much as possible, and just sending up the most important relevant bits, and then doing the same in the opposite direction, right? So opportunistically connecting to the cloud, making use of the shared information that has been like where lots of number crunching and optimization has happened in the cloud since the last time you connected, get all of that goodness back down to the robot and drive behavior.
Okay, here's one question.
Quick question.
Oh, all right.
Is it on?
Sorry.
Yeah. On the edge, is it based on Android?
The edge is Kubernetes. So in this case, we're talking about generally anywhere you can get Kubernetes to run. Right now, we're focused primarily on Ubuntu distributions, I think, which is mostly driven by our partners. But yeah, really, certified Kubernetes is something that I think was recently announced or so. And this is really Kubernetes is a compatibility layer, right? So any place that you can make Kubernetes run, then the platform is also useful.
I have a more non-technical question. Maybe it's something for the panel later on. You talked a lot about the ecosystem, about the robotics. I like that idea. Where in this ecosystem do you see Amazon, Bosch, the talks we saw before? Is that part of it? Is it three ecosystems that are in parallel? How do you see that?
I think from our perspective, what we're trying to do is build a collection of open interfaces, open data structures, open standards, if you will, but driven in a way that matches sort of the open source governance models a little bit more than maybe standardization committee style is done. And through openness and data portability and things like that, this is what we kind of hope to create an ecosystem. So I wouldn't say that it is a walled garden for Amazon or Google or Bosch or anything. It is really just more about, can we all agree about how to talk to each other, right? And so we'd like to add some structure to that to make this a little bit more palatable for industry. Right? It's been our observation that ROS is great for moving really fast and getting things up and running, right? Getting to your 80%, and then maybe you have to throw it away or replace bits and pieces as you move into production, right? And so we're trying to look to ROS for inspiration, look to ROS for like a kernel of this ecosystem through adaptations, but then try to move things a little bit closer towards the needs of industry, right? So how do we, rather than the way that I think about standardization in ROS is like standardization through popularity, right? I mean, there's a rep process and things like that. But instead, if we can look for standardization through, managed open source repository, like an agreed upon central place for all of these language updates, and choosing a technology wisely so that backwards compatibility can be maintained and things like that. This is sort of how we hope to pull things together.
Good. More questions? If that's not the case, then again, thank you very much. Please applause for Damon.